Well, welcome to this webinar presented by the IET's Anglian Coastal Local Network, which represents members in Norfolk and Suffolk. Welcome also to folks from other parts of the UK and indeed globally. I'm delighted to welcome you all. I'm Kevin Foster, I'm chairman of the Anglian Coastal Local Network, and I'll be your host for this evening. I'm delighted to introduce our speaker, Ranulph Scarborough. Ranulph is the CEO of Avaroa Cable Limited, the company responsible for building and commercializing the Mantua 1 Polynesia cable project in the Cook Islands. He's also chair of the Mantua 1 Polynesia International Cable Consortium between French Polynesia, Samoa, and the Cook Islands, responsible for the design, build, and operation of the Mantua 1 Polynesia cable. So Ranulph, over to you.
Hello everyone, thank you for that introduction, Kevin. Delighted to be here to talk to you a little bit about the One Polynesia cable project. I'm talking to you from Rarotonga in the Cook Islands in the South Pacific. So this is actually coming to you over the Mantua cable, which is quite exciting for us. I hope you like that little sort of introductory video we made just to tell people a little bit about the project. And the purpose of this talk was really just to share what we've done, some of the challenges, and what it takes to connect somewhere as remote as this. As you see in a moment, the Cook Islands is really quite challenged in terms of connectivity and how we've set about addressing that. As I say, I'm very delighted to talk to this group. I grew up in Suffolk. My dad lives just outside Woodbridge, so it's very nice to beam myself halfway across the planet to be able to speak to you. So the Cook Islands. Before I came here, I confess I had to look up where it was. This is Rarotonga, which is the largest island. Very small population, about 17,000 people, and there are 10 islands in the Cook Islands archipelago, spread over an area around the size of Western Europe, several hundred kilometres between each one, and diminishing numbers of people on each of the other islands. So whereabouts are the Cook Islands? Well, if you take a look at the Pacific Ocean, I was quite surprised just how big the Pacific Ocean is when you start to look at it. You can see Australia on the left and the US on the right, and a heck of a lot of water in the middle. And you kind of do this thing where you zoom in on Google Earth or Google Maps, and then you sort of zoom back out, and you the island disappears, and you can't quite work out where it is. But as I say, this is Rarotonga, the largest of the Cook Islands. And this project aimed to connect the two most populous islands, Rarotonga and Aitutaki, respectively, populations now around 14,000 and 16,000, and really quite small. These sit right smack bang in the middle of the South Pacific, kind of halfway between New Zealand and Hawaii. And when you talk to anyone in telecommunications, they will sort of tell you that commercially, the easiest things to connect are large numbers of people concentrated in a small area, and the corollary of that is really what we're dealing with here, which is a small number of people spread out over really quite a vast area. Immediately prior to the cable, the islands were serviced via satellite. Going right back to the late 1980s, the Cook Islands was, I think, possibly the first place to ask Cable and Wireless to move on and replace it with its own operation, Telecoms Cook Island. Initially with radio systems, and then more latterly with geostationary satellites. And then in 2013, the O3B satellite system, I think Cook Islands were first to use that, which is a medium Earth orbit system. So instead of satellites out at 32,000 kilometer geostationary orbit, these are down at around 8,000 kilometers, giving you more power, more bandwidth, but still suffered from a number of key challenges. The connectivity was pretty expensive. The susceptibility to rain fade, so heavy tropical rain causes the signal to fade and the service to drop out or at least slow down. Some challenges with cyclones and resilience. Particularly affordability has been the biggest issue. The Cook Islands is actually, as of January 2019, it obtained developed nation status. So, incomes are still modest. So clearly, for this kind of location, adopting fibre connectivity is the ideal. But with such enormous distances and the huge cost of these sorts of systems, it's very, very challenging. And actually, probably for about 10, maybe even 15 years, there was an ongoing debate about how connectivity can be improved with the fibre cable system. But this would have cost, certainly for the Cook Islands, probably a double-digit percentage of GDP, and on their own really was simply unaffordable. So this was ultimately addressed by matchmaking, really led by the New Zealand government and involving the governments of Samoa, Niue, Cook Islands, and French Polynesia, essentially looking to work together. Initially, an international treaty stating collaboration, but to work together to build a system that would connect all those four nations, sharing the costs, sharing the capacity, and trying to address the challenges that way. Now, for Niue and Cook Islands, this would be a first cable, so both countries previously on satellite. Niue is even smaller than Cook Islands, only 1,200 people, and both Niue and Cook Islands sit in what they call the realm of New Zealand. So it's a very close association, but they are self-governing nations. And then for French Polynesia, which is very close to the French state, which already built a cable in 2019 from French Polynesia up to Hawaii, the Honatua cable. This would provide resilience, second connection, and similarly for Samoa, that built a cable from Samoa down to Fiji and the Southern Cross Trans-Pacific system in 2017. This again was providing a backup solution. French Polynesia and Samoa are significantly larger, populations around 200,000 or 300,000. So the economics there are still challenging, but a little easier. The model for making this work was each of the essentially state-owned operators in each of the countries. So in French Polynesia, Office de Poste and Télécommunications, which was responsible for post and telecom services, would be the partner. Telecom Niue, the Samoan submarine cable company. And in the Cook Islands, actually, the decision was made to start a new operator from scratch, which is whatever Avro Cable is, which created some of its own particular challenges that I'll come on to. Each of those participants in the Manitoba One Polynesia consortium would provide its own funding and then work together to build and operate the system for its 25-year life. In the case of Cook Islands, so the funding came from a mix, soft development loan from the Asian Development Bank, grant aid from the New Zealand aid programme, and also some funding from the New Zealand government, all being fed into Avro Cable's shareholding in the system. So that's how we're set up. We're wholly owned by the government, by the people, with a mission to really transform connectivity in Rarotonga and Aitutaki. So if anyone's ever looked at the fantastic submarine cable map of the world from Telegeography online, I highly recommend it if you haven't. Has a great encyclopedia of the world's cables. And we sit here in the South Pacific. This is Manitoba. So it's a 3,000 kilometre system with Samoa on the west through to French Polynesia in the east. Cook Islands in the middle there. And you can see on the right the Honatua cable up to Hawaii, and on the left some of the cables down to New Zealand and Australia. So that was the challenge. How do you set about doing that? Well, I think one of the first things is to work out where you want a cable system to land. This sort of schematic gives you a sense of how the system operated. The two trunk stations, Samoa in the west and Tahiti in the west. Tahiti in the east acts as the gateways to the system, so connecting on to other cable systems with a number of branches there for the Cook Islands, for Niue, and for Bora Bora. So once you kind of got what it is you want to do, the next challenge after having signed the treaty between the nations was to run a procurement to find a system provider. The treaty itself was signed in 2017, and most of 2018 was spent doing that procurement. And Subcom, formerly Tyco Systems, was selected as the successful system provider, turnkey system provider. For those that you don't know, Subcom, they're based in New Jersey in the US and have their manufacturing facility up in New Hampshire. So we set about signing that contract with them and then getting the system design underway. So a little bit about the setup of the system. So this is kind of schematic. You have running through the middle a single fibre pair between Tahiti and Samoa with 32 repeaters about 100 kilometres apart. In the industry, they call them repeaters. They're not really repeaters. They're really optical amplifiers, Irving Data fibre amplifiers that amplify the system. And on that system, we have Sienna transmission equipment, their WaveLogic system, which is a coherent system carrying 10 terabits per fibre, 100 gigabits per wavelength using wavelength and division multiplexing. And you might wonder, why on earth would we want so much capacity? And really the answer to that is, when you buy a submarine cable system, they only really come in one size, which is vast. So we probably have enough capacity on this system to connect a large nation. We're only currently using one wavelength in each direction, and we're only really using a fraction of those. So we're quite comfortable we're going to have more than enough for any future needs. Although if anyone wants connectivity in the South Pacific, they're very welcome to contact me, and we have plenty of spare. So as well as the trunk circuit between the two trunk stations, there's also a segment fibre pair with branches into Niue, Rarotonga, which enables us to inject and receive connectivity from both Tahiti and Samoa. And then they use essentially optical broadband splitters in each of those triangles, which are the branching units, which just share optical power onto the branches and back off the branches onto the main system to enable the optical transport to be applied. In the case of Rarotonga to Aitutaki, that's what we call a domestic system. So that's only that's kind of entirely owned by us in Avaro Cable. We use that to bring traffic from Aitutaki back here to then go internationally. And similarly for the system between Tahiti and Bora Bora for IET. The connection between Rarotonga and Aitutaki is about 300 kilometres, 295, I think. To try and keep the costs of that down, that doesn't have any repeaters. When you do have the repeated system, you also have to power those repeaters. The repeaters themselves are expensive. The power injection of I think this system's around 5,000 volts DC out of Samoa and Tahiti. So quite a lot of complexity and cost. So the circuit over to Rarotonga to Aitutaki is unrepeated, no repeaters there. But to get the optical performance, the amplification uses Raman amplification, which involves having high-powered lasers at each end. I think 5 watts on the transmit and 1 watt on the receive. I might have that the wrong way around. They stimulate Raman amplification in the fibre itself to enable us to transport, I think it's a terabit we can carry between Rarotonga and Aitutaki. Creates some little interesting issues in the cable station, because if you ever have that kind of optical power leaking out of the fibre, it's quite dangerous. So all the fibres on that system actually covered in what looks a little bit like a metal shower hose, just for safety purposes. So when you look back at this design, the reason it's that kind of banana shape, as we call it, is to enable us to keep the branches short, so we can manage without repeaters and amplification. So that's the system that we went out to buy, and Subcom were contracted to build for us. One of the first things we needed to start on was really then to look at where the cable was going to land in the islands. So we were responsible for identifying those in the Cook Islands and indeed building the cable landing stations, which I'll come back to. And similarly, the other parties did the same in their own islands. Bringing a cable ashore, it's actually interesting. There are a lot of cuts to cables around the world. I think on average there's one every few days. We're very lucky here in the South Pacific. The water is tremendously deep, 2, 3, 4, even 5 kilometers deep, which means there's very few threats to the cable from things like anchoring and fishing. But where it does get risky is where we come into these atolls, islands. They are essentially extinct volcanoes, so they come up like cones from the bottom of the sea, very steeply, often at an incline up to sort of 60 degrees. And then they hit a reef, and coming across that reef, it's shallow, there's a lot of coral, there are risks from boats, and also we get some quite interesting weather in the South Pacific with frequently cyclones up to category 5, which create huge waves which mobilize big rocks, which can be really quite unfriendly to cables. So in this case, we elected to go through one of the reef passages. There's probably half a dozen or so of these reef passages around the island. So when the waves come in and break over the reef, these are the exit points that let the water back out. So they're nice and deep, but they do experience some really quite strong currents, so they're quite tricky to work in. But that's what we selected here on Rarotonga for the Manatee cable landing here, at a place called Rutaki. And then over on Aitutaki, again, we looked at a few different options. Some suggestions quite easy over to the port on the left there, but we really didn't want to be near ships and anchors and those sorts of things. Plus, you can probably see it's a long way out to the reef over there in the west. So we took a nice quiet landing point by the old airport runway there. Where it's still about 700, 800 meters across that reef before we get into deep water. And also that creates a little bit of a challenge in that it's 7, 8 kilometers back to the cable landing station. You can just see the little runway there. That's quite interesting. That was built during World War II by the Americans as part of their efforts in the war in the Pacific. And actually, that airport was on the Coral Sea route, famed by seaplanes and the like for hooking up French Polynesia to the US during the 50s and 60s. So that's where we chose to land the cable. Once we'd identified those landings, then the system kicked off with a detailed marine survey across the whole 3,600 kilometers of the system route. So this was doing high-resolution sonar and various other measurements to look at the seabed and try and work out exactly where we wanted to put the cable, avoiding obstacles on the seabed. Once those reports came back, We pored over them with technical advisors and cable manufacturers to work out exactly what things we wanted to avoid and levels of armoring for the cable. Similarly, survey work was done on the landings to make sure everything was good for where we wanted to put the cable. This was done, probably took a couple of months to do this through the middle of 2019. And then once we had sort of the design of the cable in terms of what we wanted where, it went on to cable manufacturing up in Subcom's factory in New Hampshire. This isn't actually a picture of their fabrication facility. It looks very similar to this. They wouldn't let me take a photograph, unfortunately. Quite a scary machine with lots of things flying around, building the different types of cable that we required. These are the sort of 5 common types. So most of what we have is the stuff on the left. So this is SL19, 90 millimeters. You can see the optical fibers up the top with a fine strands there. Those are actually covered in a plastic coating. So if you've not seen optical fibers before, they're even smaller than that. And then gradually, as we go from left to right, all the way through to double armored cable, which you put in the most challenging locations, such as through the reef. So the whole design of the cable with different cable types knitted together, so when the cable ship came back, it would put in the right kind of cable in the right kind of location to match up with the survey work that was done. It is quite interesting, particularly in deep water like this. The Subcom guys said to me that often the cable doesn't actually touch the bottom of the sea until as much as 40 kilometers behind the ship because of the depth of the water and the distance. And yet they're incredibly accurate in terms of placing the cable exactly where the sonar survey said was the right place to put it. So pretty sophisticated operation with very fine control over ship's positioning, cable tension, and dropping the cable on the seabed. So the cable manufacturing got completed around September time up in New Hampshire. We went and did a load of factory testing, make sure everything worked properly with all the expected optical performance, so that once we got the system delivered, we didn't find there was a problem. And then the cable was transferred to a freighter. Cable ships are in quite short supply at the minute, so it wasn't loaded onto the cable ship, but onto a freighter to move to the South Pacific. Pretty immense journey, 17,500 kilometers through the Panama Canal, and then met up with. This is actually the hold of the ship, the cable being loaded, 3,600 kilometers of it. It's pretty smelly because it's coated in tar. The loading process takes about 2 weeks. These guys walk backwards in a circle, 3,600 kilometers for 2 weeks, loading the cable very carefully. So not a great job, but it's pretty critical because if the ship hits bad weather, cables can move around. They're pretty heavy and can be rather disastrous. This is Subcom Reliance, the ship that did the actual work to lay the cable. This normally sits in the South Pacific as the regional repair vessel. So all the cable operators pay into a scheme to keep the vessel on standby. So if there is a cable cut anywhere, it's immediately ready to steam off to do the repair. It will keep spare parts for that particular cable system on board. The Manitou cable had to be transferred to Reliance. The ship either sits in Samoa or more commonly New Caledonia. So again, that took a couple of weeks of transfer to get it from the freighter onto the cable vessel, ready to start the cable line. And then the other part of the system is obviously the critical transmission equipment. I think I said that we have Sienna WaveLogic 4, I think it is. They're very clever optical transmission equipment. So this was down in Memphis, where we did the factory acceptance testing with all the cable stations sort of set up in the lab environment, connected together through reels of cable, just to check that everything worked before we got it down to the South Pacific, and make sure we didn't find a problem when we got there. So cable laying started in Samoa around October 2019. Quite a few logistical challenges with that. We happened to start just at the point that Samoa had a measles epidemic, so this was pre-COVID. Created quite a lot of challenges in terms of getting people in and out, and really highlighted many of the logistical issues that you have operating in the South Pacific. Rarotonga really gets its supplies every 2 weeks by ship, so getting stuff in and out is tricky. We had a couple of particular challenges on materials. A fishing boat ran aground on the reef. The port tug went out to try and help it. In the process of doing that, burnt out its engine. That then meant that the supply ship couldn't dock in winds over about 11 knots. So we kind of went down to one supply vessel every month if we were lucky. So logistics were a big challenge, and things would run out regularly. I think we went without mayonnaise for nearly 2 months, but we managed to survive. So the cable laying kicked off in Samoa in October. This is us landing the cable in Rarotonga. So you can see the cable ship out there. Initially, a rope is brought in by a small boat, and that boat brings a bigger rope, and then is used to haul in the cable itself. It's quite a big operation. As I say, there's 700 or 800 meters of reef there, and a big team to manhandle the cable and get it safely ashore. Having gone through all the effort to manufacture it and ship it across the world, we don't want to have any problems on it. It was a great day when we landed the cable. The Prime Minister and the Deputy Prime Minister were very excited and got their photo opportunity. We then moved on from Atataki to land the cable in Rarotonga. You can see the reef passage there I described that we brought the cable through, and you see the older Rarotonga volcano in the background. Once the cable's in place, we apply armoring to it. This is a split pipe across the reef that divers go out to apply. This is the cable after it's been in for about a year or so. We only actually armor it down to about 20 meters because, again, another challenge here is for divers going deeper if they have decompression sickness. When they did the Honatua cable in 2010, a diver did get decompression sickness in Tahiti, and they had to be flown at low altitude to New Zealand by military jet, which was both unfortunate and very expensive. So we've chosen locations away from threats, and hopefully 20 meters will be deep enough for us. So while all that was going on, separately we had a lot of work to do to get the landside stuff going, various environmental impacts and quarantine for the ships, and new legislation to be passed. Actually, under the legislation that prevailed at the time, Telecom Cook Islands had a legislative monopoly, so we were trying to get that legislation through. So some would argue Avro Cable was operating illegally in building a cable network until such time. So, but the Solicitor General said, "Don't worry, if you get fined, we'll just give you the money back." During that time, so we had to go through consultations. Actually, when I first arrived here in early March 2019, quite a lot of people were against the cable. It took a little bit of persuading that this is really a fantastic investment in their infrastructure and was to everybody's benefit. And these cable systems have been shown to be very low environmental impact, so really there shouldn't be too many concerns. We had to pick good locations for our cable stations. We didn't want to leave them near the sea because of cyclones and tidal surges and the like, so we identified locations next to Vodafone's existing teleport. You can just see their two dishes probably down the bottom left there in their central office, and similarly on Atataki next to the hospital. So nice safe sites, and also crown land, which is quite key because land ownership in Polynesia is quite a tricky concept, which would be worthy of an entire webinar, I'm sure. Building cable landing stations with all the requisite backup power and air conditioning and fire detection, fire suppression and building monitoring is pretty challenging to do quickly. From when I first started here, as I said, in early March, through to really needing these in place by December, we really had no choice but to look to prefabricated systems. So these are our two cable landing stations provided by DXN in Australia in Perth, prefabricated in the factory and then shipped to us, which was a great way to get all the things we needed under a kind of factory quality and shipped to us. Again, logistics not easy. They had to go by air suspension lorry right the way across Australia, onto a ship from Brisbane to Fiji, and then from Fiji to here. We then had to compete with everybody's Christmas shopping on the ship and try and persuade them that a new cable system was more important than tinsel and Christmas crackers. But we were very relieved when they arrived in October 2019, craned onto site, concreted to the ground and bolted down, as in cyclones. Containers frequently are seen to be rolling around, blown by the wind. Everything was all set up inside. Sorry, that's not a great photo, but it's a little bit cramped. So what we've actually moved on to do, we're only really just doing this now. These systems were great to get us started, but we're actually building enclosures over them to give a little bit of longer term protection. The environment's very corrosive here. The ultraviolet combined with a lot of humidity and salt means that things decay incredibly quickly. So these will help us protect these assets over the next 25 years for the system. We also had to build the land routes, so mobilise the team, get all the equipment over to Atataki. Vodafone, or Telecom Cook Islands, who now trade as Vodafone, did that work for us, did a fantastic job. There's the ditch switch going over to the island. And another challenge, concrete actually is very tricky to obtain here. It's very expensive because of resources. All the sand has salt in it. So we use these aluminium prefabricated boxes to build the land route. And then, oh yes, look, here's a picture of me. This is the beach manhole, which is the biggest manhole where the land cable and the marine cable meet. So all of that work of designing the cable, fabricating the cable, shipping the cable, installing the cable, followed by commissioning and testing, all the land route, building the cable stations to get the whole system together. Then the final splice was done in January 2020. We were pretty lucky because that was just as COVID was starting to rear its head. We did have one problem with the ship, that one of its positioning system thrusters failed about 5 days before Christmas. So it made a dash to Tahiti, and the team that had been on board already for 70 days managed to wangle a Christmas week in Tahiti, which makes us a little suspicious about the problem they had. But they were pretty much back quickly in the new year to finish the system. And through January through to July was all the commissioning and testing. All the individuals that were sent to do that got pretty much stuck in the country. It took quite a few more months to get out. But we declared the system ready for service on July 2020, which I think through all of that was only about 2 weeks late from the original plan. So we're pretty pleased with that. And there was quite a jamboree. But of course, while all of that was going on, here in the Cook Islands, building the cable was not the main thing we had to do. Our mission was to improve the speed of the internet, the affordability of the internet, the reliability and resilience. So we had to also in parallel start our own company, our own operator, get licensed, build a team, build an office, build products, and get all that stuff ready so that we could be a wholesale operator, providing retailers in the Cook Islands with international and connectivity wholesale capacity. So that's actually a picture of Tanya, one of our systems engineers. So we've got a good homegrown team, except for me. I'm the one parachuted in. We also had to set up across all the partners, all the operations and maintenance practices between the 6 stations. For my sins, I chair the operations and maintenance committee. So we have some challenges with the French in the east in Tahiti. In the west, we have Samoa, who's the other side of the date line. So it's the same time but a different day there, which always creates a little bit of a headache. But getting all those things working between everyone was a challenge, but it's working well. Of course, the cable system takes us into Tahiti and Samoa, but that's not a great deal of use. The main interest is in getting to internet peering points. At the moment, we go out through Tahiti onto the Honolulu cable and over to Los Angeles. That's a total of about 8,000 kilometers. Just to give you a sense, London, New York is 5,500 kilometers. So it starts to give you a sense of some of these enormous distances we're dealing with. And what we're working on at the moment is opening around westwards as well, down to Sydney. A lot of Cook Islanders are in New Zealand and Australia. So at the moment, when you talk to them, you have to, the signal has to go across the Pacific twice, which does create more latency than we'd like. But it's not too bad to the UK. So we aim to open that western route as well. And that then gives us also some diversity in that if we have a problem on either route, we can switch traffic the other way. But yeah, distance is a pretty big challenge. So Telecom Cook Islands, in anticipation of the cable, branded themselves as Vodafone in anticipation of competition. We were quite excited that after RFS, we were the first to get live customer traffic on the cable, which we thought was a great result. But actually, there's a little secret behind that as well, because going back to around April time, Vodafone had a bit of a problem with their steerable O3B dish over in Atataki. Those steerable dishes do not like the salt and humidity and ultraviolet, and one of those dishes packed up, and COVID made it very difficult to get parts. So we actually put their traffic onto the cable in late, I think actually it's late March 2020. So we couldn't tell anyone because we weren't supposed to do that, but it got them out of the jam. Otherwise, they were having a 10-minute outage every 40 minutes while the dish wound back across the sky. But for me personally, having arrived only in the kind of beginning of March 2019, to already been carrying, and with no company, no people, no office, no nothing to go to carrying live customer traffic on an international submarine cable system in kind of 12 months was a pretty proud moment, I think. And actually, we also saw some interesting dynamics with the satellite side, because it's difficult for a satellite operator that's a monopoly to see any reason to reduce its prices when there's no competition. But actually, just the threat of the cable coming along, we saw O3B dramatically reduce their prices about 12 months ahead of the cable and sign Vodafone into a kind of quite a long-term deal. But nevertheless, Vodafone moved across. We've already tripled international capacity. And perhaps importantly, we've seen retail prices here drop by as much as 80 to 90%. And that's against the backdrop of really some quite big economic challenges. Maybe 70, 80% of the economy here is tourism. And with the border shut since about June 2020 and still shut today, that's been particularly challenging. But despite that, we've seen traffic grow, services improve and prices fall. And I think when the tourists return, the border reopens on the 13th of January, we will see that really start to deliver even faster speeds and even lower prices. And again, one of the key parts of the strategy, New Zealand government were quite smart when they provided their funding, because they said, well, we're not just going to give you funding, we're going to ask you to liberalise the market as well. Telecom Cook Islands was part owned by the government, and it's always a little bit of a challenge when you're making money out of the operator to also liberalise the market. But that has happened now. We have a new regulator, a Competition Act and a Telecoms Act. ACL's as of December 2019 is legal, which is nice. And we've seen the licenses there. I think 7 new entrants have been licensed. It's still early days. Some of them have started to build. No one actually connecting customers yet, but I think it's promising to see that there's potential for competition to deliver in what is really quite a small island and quite a small population. So that's nearly the end. I've got one last little video we just made last week, which is a little celebration of us running for about 15 months. Let me just show you that. Okay, well, look, hopefully that's been interesting. I think just a couple of final points, really. I think the video shows there, you know, one of the interesting things as well. We are starting to see the economy here diversify. Starting to see people doing more digitally orientated things. It wasn't really possible with the quality service before. So this infrastructure really is starting to underpin an economic diversification transformation, which is really very important for this kind of economy. And I think the other learning is that I certainly had been a little skeptical that the kind of capital project like a submarine cable at huge expense really can be made to work for such small populations. But having gone through it and all the business planning and the commercialization, you know, Avro Cable is self-sustaining now. We don't have any further funding from government. We're repaying our loan funding from the Asian Development Bank, and it really does work. And this kind of model, I think we're seeing increasingly across the Pacific and to some extent in the Caribbean as well for connecting small nations. So it does work. So thanks very much, everyone. It's been a pleasure to tell you about this, what I've been up to the last couple of 3 years, and I appreciate your time.
Thank you very much, Ranulph. That was a great presentation, and absolutely fantastic achievement to bring it in within 2 weeks of planned. I mean, that's some tremendous engineering challenges there. And thanks for giving us an insight into what must have been a fantastic experience for you. We're going to go to Q&A now. I'm going to ask my colleague George Williamson to handle the Q&A for you. So I'll hand over to George.
Thanks very much, Ranulph. Question from Lewis McCann in Milton Keynes. He would be interested to hear some more of your background. I guess he's interested to understand what sort of background you need to have to cover off all the aspects of the job that you've just been doing.
Okay, thanks, George. Yes. Well, actually, I was with BT for quite a while, 12 years or so. I actually started there in the research area, and then ended up running some of our broadband projects in the UK to take fibre to tricky places. We did quite a big project in Cornwall where we gosh, going back to, I guess, starting about 2010, trying to roll out fibre to difficult places. Working indeed with George and Kevin on that to try and tackle the challenges, and we indeed took a cable out to the Isles of Scilly, a redundant cable that was picked up and repurposed. So I think those projects certainly gave me a taste of how important doing these sorts of projects for the impact they can have, but also you do need quite a lot of different skills. Really, we're a very small team, so you need to know a bit of the tech, enough to keep people straight. But telling the story actually like this is important, because it does keep people on board and supportive, and help people that, you know, you're asking them to invest a lot of money in these sorts of systems. So yeah, I think that period of probably the gosh, nearly 10 years or so spent in BT trying to work out how to get fibre to people was the most influential in being able to help the Cook Islands with this ambition, really.
Thank you for that, Ranulph. I have a question from an anonymous attendee. This one, he asked quite an interesting question. It's, how do end users in the Cook Islands access this? Is it via fixed wireless, mobile, or wired via cable, XDSL, whatever?
Yeah, so that's a great question, and it's still a challenge. There's actually quite a lot of 4G here, which gives, you know, pretty good speeds. There's an ADSL network which is not so great. The copper's not in great shape, and you know, the speeds are not fantastic. But Vodafone Cook Islands actually have been rolling out fibre to the premise quite a bit. They have a plan over the next 12 months or so to make that available to most properties. They've obviously focused on the big hotels and the more attractive commercial propositions initially, but that certainly you know, is key. And it is challenging because you know, some users do say, well, hang on, you built this cable, why isn't my internet better? And you know, you do have to explain to them that, look, you know, this is a challenging economic time. You know, Vodafone have to do work to improve their access network. They're doing that. Competition is part of the remedy as well, and it is going to take a little bit of time. But I've certainly been to other Pacific Islands, and I think actually here with O3B, Vodafone have you know, had been doing a pretty good job in some pretty challenging circumstances. So so it's probably something I learned in BT as well, which is, I think the telecommunications network or internet network that's good enough will never be invented, probably. So I think you learn to live with it a little bit.
Okay, next question. Thank you for that, Ranulph. Next question really is related to the time to repair, and a question from Graham C. What's the likely longest time to find and repair a breakage in the longest run of the cable? And Alex Wood asks a supplementary, saying that cable is cut somewhere almost every day. How quickly is it repaired, and how are they repaired?
Yep. So another great question. If you're not in one of these repair agreements, cooperative agreements, and there's one for the UK. I think it's there in the North Atlantic one. Here it's the South Pacific one. If you're not in an agreement, it's really challenging, because you've got to go and persuade a cable ship to come away from some, you know, could be hundreds of millions of cable lay projects that they're on a contract on penalty clauses to divert away from that to come and fix your cable. And on the open market, there's been suggestions, you know, this could be $6 or $7 million US for a repair. Yes, huge amount of money, and it could take, you know, it could be 3 months. So obviously that's a huge concern. So these cooperative agreements that have the ship on standby. So the one in the South Pacific Marine Maintenance Agreement, the contract for that is with Subcom. So the Reliance ship sits there and waits, has most of the spares already loaded on board. From the point the ship is called, the estimates are the repair will be done in about 7 days. First of all, you can't call the ship until you've found where the fault is, and that's always a challenge. So all the stations have got OTDRs, optical time domain reflectometers, so they can send a signal down the cable, reflects off the break, so it can tell you how far away it is, and through that you can pinpoint the location. It wouldn't be the first time that a ship has been called for a repair on land, so it's quite important to get that right. And also, through being in that kind of agreement, you've already got pre-negotiated repair rates, typically around $500,000 US for a repair, because you've got to mobilize the ship and all the crew and travel, and you know, the ships are kind of $50,000 a day by the time you've got all the running costs and so forth. Once they get on the location, particularly in these waters, imagine if you've got 5 kilometers of depth, it takes a long time to put a grapple down to try and find the cable, pull it back up, and it can take a few times to find the cable. They'll bring it back up. Of course, if the cable's sort of tight on the seabed and it's 5 kilometers deep, you can't really pull that to the surface. So you pull up each end, and then you would typically splice in another 5 to 10 kilometers of spare cable back in. Making those joints is obviously critical, but it's very similar to the jointing process in cable manufacture. Once they're together, they're x-rayed on ship just to make sure there's no issues. Testing is done, goes back down, and the other thing that where care is needed is to power down the cable, obviously with that 5,000 volts from either end, powering repeaters. From a safety perspective, that has to be managed fairly carefully. So yeah, the repair arrangement is challenging. As I say, we're very lucky here with deep water. Cuts are very rare. If you go over to somewhere like Singapore, where there's lots of shipping and lots of shallow water, much more challenging. But there was a cable cut down in Tonga in 2019. They didn't have an OTDR. It took them quite a long time to work out where the cut was, and I think the entire nation was off air for a couple of weeks. We will aim. We have the O3B system as a backup at the moment, but the aim will be to put east and westward connectivity to give us that resilience. So that's our aim. So that's how it works. Paying into that marine maintenance agreement is one of the biggest operational costs. It's the order of a couple of $100 per kilometre of cable every year, which for little operators like us is quite a lot of money, but it's critical for that kind of critical national infrastructure. So,
thank you for that. Question from Alex Wood. What were the local objections to the cable, and how did you overcome them?
Well, they were sort of mixed. Some thought it would mess up their fishing. So we had some environmental consultants come in, and we ran various sessions, and we brought along samples of cable. But I think people thought the cable would be sort of, you know, a meter in diameter or something. They had a lot of misconceptions. So a lot of it was just about telling people what it would do and how it would work. Some were concerned that, you know, we might be building a white elephant that would land the nation with debt for many years to come. So I think we need to give them confidence that, you know, we had a lot of work to be confident that, you know, the cable would pay for itself. And there were some concerns about the impact on, you know, young people of, you know, sort of inappropriate online content. I think the islands have been a little bit protected from that kind of thing. I mean, it's interesting. Previously, there had been no free Wi-Fi. You see tourists wandering around looking for free Wi-Fi. You explain to them, well, there isn't any because it was too expensive. You didn't used to see kids with smartphones. They're relatively isolated from the internet. Obviously, getting that sudden exposure. So it did a little bit of work with Vodafone as well on sort of online safety and cyber security and some of those sorts of things. So those were the main things, I think.
Okay, another question from Saleh Tarada, and he asks, or she asks, I'm not sure, sorry Saleh, what systems were used to communicate with the project team before putting the cable system into operation?
Yeah, so prior to the cable, the nation was on the O3B system, which is pretty good actually. The main issue was the cost. So as a team, we would you know, do regular Zoom calls and so forth. So that sort of stuff would work. It was really the kind of capacity per user that was the challenge. But with the high prices, that meant that, you know, you could usually make those sorts of things work. But yeah, we rely a lot on Teams and Zoom and all those kinds of things, but also meeting up quite frequently for design reviews and face-to-face sessions. Of course, that got tricky after sort of mid-2020 with all the borders closing, so it has been much more challenging since then. But we're looking forward to reuniting soon, we hope.
Jane asks, with the 40-kilometre cable drop, do you have to have an exclusion zone to prevent other shipping from affecting the cable while it's being installed?
Yes, that's right. That's actually not too much of a problem because there's not a lot going on in this part of the ocean. There is a lot of space out here, so there were no system mariners and all those sorts of things. There is a fair bit of fishing, but that's also monitored by the government of Chinese fishing. So even in that situation, the cable goes relatively deep quite quickly off the back of the ship. So I think they're able to monitor that through what they call AIS, automatic identification system. So they track other vessels in the vicinity, but it's not like the English Channel or some of these other congested waters. It's you don't see many ships in this part of the world.
Thank you, Ranulph. From Malcolm, regarding test and diagnostics, do the OTDR systems run on spare fibre or over the transmission fibres? And is this only used upon faults, or is it used proactively as well?
No, we don't use it proactively. We don't have any spare fibres with which to do that. So yes, it's just there ready to use on the system when there's a problem, which does create a little bit of a challenge in case people get a little bit rusty with their knowledge, and that is one of the challenges with this sort of system, in that you get all the training and so forth in how to deal with the cable cut, but you hope one never happens. So it's a little bit like the military, where you're sort of training for battle but hope it never happens. So we do kind of regular practices just to think through, get the kit out, make sure it works, try it on some sort of spare reels of fibre, just to kind of keep the skills tuned up, really. But yes, it would be great if we could monitor it in service, but we aren't able to do that, unfortunately.
Alex Wood notes that you showed 5 different types of cable for more or less risky parts of the cable run. How much does the price vary between them?
Quite a lot. I think all the armouring and so forth, not only is it more expensive to make, it's much more fiddly to join. It is heavier to transport. The actual numbers are kind of commercially confidential, but yeah, the SL19, the thin stuff, is you want to use that as much as you can, really. The others are only for a fraction of the system, really.
Okay, and Alex has got the final question, so well done for answering, looks like 15 questions. Oh no, one coming up there as well. Alex says, what sets the cable's 25-year lifetime? What are the key factors?
Okay, I think, so actually it's really the repeaters. Unrepeated systems, I think, tend to have a much longer life, and I'm not even sure. Probably someone like Kevin would know better than me, but I think the long-term aging, people haven't yet really seen the maximum of that, because I think we've seen systems up at 30, 35, even 40 years. But for these repeated systems, I believe it's so the optical amplifiers that amplify the signal use erbium-doped fibre. And they have pump lasers to get the electrons excited for the stimulated emission that the amplification uses. And I believe it's those pump lasers that degrade over time, and really beyond 25 years, it becomes uneconomic, really, to repair and improve them. I mean, you could, in theory, go and replace them, but by the time you've mobilised a ship, got out there, picked it up, replaced them, and you don't know how many you've got to do. Typically, by the time 25 years has passed, system capacity has increased enormously. So usually at about that sort of point, everyone goes, well, we need a new cable now. So that tends to be the marker point. There is work, system life has been extended by a few years in some locations, but in most places, the business case has been demonstrated, all the traffic's there, and it's then sufficiently important that a new cable is usually what people then go and do. So that's really where it's driven from.
Okay, so our final question then, Graham C asks, in current understanding, what is the practical maximum run of continuous cable which could be laid subsea?
Oh, what an interesting question. I think it is really probably not so much limited by the optical transmission. I think it comes down a little bit more to the powering of the repeaters. So I think the biggest continuous systems are the ones over here in the Pacific. The original Southern Cross system from Australia and New Zealand to the US, which calls in Hawaii. And part of that is about having repowering the system in the middle there. Similarly, the replacement system, which has just been built, the Southern Cross Next, and also the Challenger Hawaiki cable. So I think I'm right in saying that the transmission capability with repeaters and so forth, you can cross that entire distance, and there isn't really a bigger distance than that. So it's really the powering that I think dictates the number, the intermediate landings rather than the transmission itself. The other very long system, I think, is the CME-WE3, the Southeast Asia, Middle East, Africa, Western Europe. So that goes from near my home in Cornwall and in Goonhilly right the way around to Japan and Korea. And I think there's continuous transmission all the way through on that. And I believe that might be the actual longest system, because it goes all the way around Africa, around India, and then all the way around to I think Singapore, Korea, and Japan. Hopefully that answers the question.
Great. Well, that I think is the end of our question set. Well done for getting through that, Ranulph. Thank you
very much. Thanks for the great questions. It's good, challenging ones.
Yes, indeed. Thank you to the audience.
So thank you, George. Thank you, Ranulph, and for great presentation. Very, very interesting. Absolutely fascinating. And I really I wanted to add one question of my own, if I could be so bold, is to ask you, what was the toughest challenge?
I think actually the toughest certainly wasn't the technology. I think it was probably dealing with the landowners. Just very briefly. So the Maori tradition, because Cook Islands is Maori, and the Polynesians came from Asia, they think through Polynesia, and then down and populated New Zealand. And the tradition of land is that it's hereditary, and that was codified in legislation, I think 1905, in sort of colonial times. And that means that any piece of land, you can't freehold land, it has to pass from owner to their descendants. So I don't think they really thought this through. So by the time you go through a few generations, you end up with every piece of land owned by hundreds, if not thousands of people, and you have to get their agreement. So all we wanted to do was to go about 30 meters from the road to the beach with our cable. But we had to have so many meetings with literally hundreds of people to get their agreement. They all wanted to agree, and they all did agree, but just the logistics of getting that and getting it in place. Because what we didn't want to do was build the cable and then find there were any kind of problems with the the land we would cross. So I think actually that was the hardest, particularly over in Atataki, where I went to quite a number of meetings that were held entirely in Maori. I had no idea what was going on. Some people would stand up and say what sounded like very angry things, and then they would explain, no, that's fine. They're complaining about something completely different. So land actually here in Polynesia was the trickiest thing, but a great. I now know far more about Polynesian land ownership than I ever want to know. So that was the trickiest.
Thank you, Ranulph, and it's just absolutely fascinating. So thank you for the talk. Thank you for the work that you've put in to provide such an excellent slideshow and commentary. It's very much appreciated. And thank you to George for collecting the questions and grouping them and asking them on behalf of the audience. Once again, just like to thank our team who put the webinar on tonight, not only Ranulph, who provided the excellent content and delivery, but George, Ian and Julie behind the scenes who set the webinar up. Very much appreciated. So I think that leaves me finally on behalf of the IET Anglian Coastal Local Network to thank you, the audience, for your participation, and thank you for joining tonight. That concludes the webinar.